Hi friends, welcome to my channel Interesting Engineering. Today let's discuss about instrument transformer. Almost everybody would be familiar with the transformers. So transformer consists of primary and secondary winding and it operates on principle of mutual induction. So that is the basics of any transformer. So here what is the difference between a normal power transformer and instrument transformer is these instrument transformers or works along with other instruments to measure higher values of currents and voltages. So this is an instrument meant for measuring higher values of voltages and currents. We would have all known the instrument for measuring current is ammeter and the instrument for measuring voltage is voltmeter. Suppose if these ammeters and voltmeters are meant for measuring higher values of current such as beyond in the ranges of some kilovolts and in the ranges of mega amperes in the ranges of amperes, then we can't able to make use of those ammeters and voltmeters for measuring those higher values. Suppose if we make use of those instruments for measuring higher values of currents and voltages, it causes damage to the instrument because it can't withstand those higher values. So in order to avoid such problem, we go for this instrument transformer. So by making use of this instrument transformer, we can able to extend the ranges of ammeters and voltmeters beyond its operating range. That's the major advantage of using this instrument. So in instrument transformer, we have two types. One is the potential transformer, also called PT, and the other one is the current transformer, which is otherwise called CT. So potential transformer is meant for measuring higher values of voltages and current transformer is the instrument meant for measuring higher values of currents. So these are the two different types of instrument transformer. So in potential transformer, let's discuss about this potential transformer first. So in potential transformer, normally suppose this is the working field. Consider this is the input side. Suppose if we want to make use of this here in this power line, if the voltages are of about a few kilovolts, then we have to introduce apart from voltmeter, then we have to introduce a instrument transformer so that the higher voltages are stepped down by means of these transformers. So these instrument transformers or help in stepping down the higher values of voltages into the minimum operating range. Suppose in the case of potential transformer, we have higher number of turns of primary winding connected in across a so let's discuss about this potential transformer first. So this is the power line which is connected across a load. So here we have a higher voltage range of about 230 kilovolts. Consider this is about some higher values of voltage. So if we want to measure this higher values from this power line, then we have to introduce a potential transformer. So this potential transformer consists of number of turns of primary winding connected across the voltmeter. So here compared to the number of turns of primary winding, the number of turns of secondary winding will be less, and through the secondary winding we connect a voltmeter here. So this is the voltmeter, and here we have many turns of primary winding and lesser number of turns of secondary winding, and this is connected across the voltmeter. So this voltmeter is going to measure this voltage range, and before measuring this higher voltage is being reduced over here to some volts or millivolts based on the instrument used here. So that is the major advantage of using this potential transformer. So the potential transformer reduces the input supply voltage to the normal voltage level required for the required based on the meter connected over here. So this is about the potential transformer. And now let's discuss about current transformer. In the case of current transformer, there will be a single or lesser number of turns of primary winding connected across the load, and across this we have a single or lesser number of turns of primary winding connected to the load, and across this we have many turns of secondary winding connected to the ammeter over here. So this ammeter measures the current across this. So this primary current is represented by IS. This IS flows through this load, and this IS is not dependent upon the secondary winding current. So here the IS is being measured is of higher value, and this is being reduced through this mutual induction concept, and here the less value of current reaches to the ammeter, so that the ammeter doesn't get any damage. So this is the current transformer. So what's the difference between a current and potential transformer? Potential transformer measures the higher voltages, whereas current transformer measures the higher values of current. So in potential transformer we have more number of turns of primary winding, whereas in the case of current transformer we have a single or less number of turns of primary winding, and this potential or current transformer reduces the value of input voltage or current, so that the meter connected over here doesn't get any sort of damage. So that is about this potential and current transformer. And the next thing here, let's discuss about disadvantages of shunts and multipliers. Why I have I have introduced about shunts and multipliers is, as I said earlier, the instrument transformer is meant for extending the range of ammeters and voltmeter. In our previous lecture, I have already said in order to extend the range of ammeters and voltmeters, we go for shunts and multipliers. So shunts and multipliers extends the range of ammeters and voltmeters. So these shunts and multipliers can also be used only up to certain ranges. That is, the shunts can be used only up to few hundred amperes, whereas the multipliers can be used only up to certain 1000 volts. So beyond this range, if we want to extend, if we want to measure the current and voltage values, we go for this instrument transformer. So that's why we make use of instrument transformer apart from shunts and multipliers, instead of shunts and multipliers. So shunts and multipliers, the shunts and multipliers extends the range of ammeters and voltmeters, and they can do only up to certain amperes and certain volts. So apart from those ampere levels or voltage level, if we want to measure higher values, then we go for instrument transformer. So why we should go for this instrument transformer? Why can't we make use of the same shunts and multipliers beyond those ranges? If we make use of those shunts and multipliers for higher values of voltage and currents, they consume large power from the input side. So that's the major drawback. And the most important thing is there needs isolation of the measuring circuit from the input line. That is, if the voltage and current values are heavy at the input side and the measuring circuit is connected directly over the input side, in that case it causes damage to the measuring circuit, and also it causes severe damage even to the personnel working there. So in order to avoid such critical conditions, we go for this instrument transformer. So let's discuss about the advantages of instrument transformer. The same thing that we are going to discuss even here also. So it produces practically same reading irrespective of instrument constants. Even if we make use of shunts and multipliers, at that case the constants of the instruments will be added upon to the readings obtained in our instruments. So when we make use of this instrument transformer, we can eliminate those constants. We can obtain exactly the same reading what we have, obtain exactly the same measurement what we get from the input side. Then the moderate rating instruments can be used for large measurements. As I said earlier, the instrument transformers, when we make use of this instrument transformer, we can even make use of lower values of ammeters and voltmeters for measuring even higher values of currents and voltages. And low cost and easy replacement. Since we have a moderate value of instrument used here, the cost of the instrument can be reduced, as well as when there occurs any sort of problem or any damage to the instrument, we can able to easily replace any instruments in between the measuring time. So that's the advantage of this instrument transformer. And the most important advantage of this instrument transformer is it provides good isolation from the higher values, as well as it provides safety to the operating personnel. So the last 2 points are the most important points of advantages of the instrument transformer. Then as we are all clear about what is an instrument transformer, what is its function, and what are all the what is the need to make use of this instrument transformer. So when we make use of this instrument transformer, we must know what are all the terms involved in its operation. So let's discuss about the different terms that describes about the operation of this instrument transformer. The first term is the transformation ratio. So in transformation ratio, the ratio differs for both the types, for both current and potential transformer. So in the case of current transformer, transformation ratio is represented by capital R, and it is nothing but the magnitude of primary winding current divided by magnitude of secondary winding current. So when we make use of a current transformer, the transformation ratio is represented by ratio of magnitude of primary winding current to the ratio of magnitude of secondary winding current. And in the same way, for potential transformer, it is primary winding voltage divided by secondary winding voltage, which is nothing but the transformation ratio can represent it by capital R, and it is equal to the ratio of the magnitude of the primary phasor divided by magnitude of secondary phasor. The next ratio is the nominal ratio, and this nominal ratio will be represented in each panel of the instrument transformer. In any instrument transformer, in its panel, the most important ratio described is the nominal ratio, and it is represented by K suffix n, and it is equal to rated primary current divided by rated secondary current. And for potential transformer, it is rated primary voltage by rated secondary voltage. The next ratio is the turns ratio, and in this turns ratio for current transformer it is denoted by small n. N is equal to number of turns of secondary by number of turns of primary, and for potential transformer it is number of turns of primary by number of turns of secondary. So you should remember that in the case of primary transformer there's only a single turn in the primary winding, whereas in the case of potential transformer there will be many number of turns in the primary winding. So based on that only the turns ratio differs in both the case. So it is n is equal to number of turns of secondary by number of turns of primary, whereas for potential transformer it is number of turns of primary by number of turns of secondary. So at the last case we go for burden of instrument. So burden differs based on the load. So the total secondary burden is occurs in the secondary winding side, that's why we are representing here total secondary burden. So total secondary burden will be the ratio of secondary winding induced voltage square by the impedance of secondary winding circuit, total impedance of secondary winding circuit. Whereas for a current transformer the total secondary burden will be equal to secondary winding current square divided by total impedance of secondary winding circuit. So based on current and potential transformer, in the numerator side there will be either voltage or current. So it is secondary winding current square divided by total impedance of secondary winding circuit. So by means of these definitions we can able to find out the turns ratio, nominal ratio, and the burden of any instrument transformer. So I think it would be clear about the current and potential transformer. So in detail we shall discuss about current and potential transformer in our forthcoming videos. So thanks for watching. For more videos, keep watching. Please subscribe and share. Thanks for watching.